Hi everyone and welcome to my channel. We have the exponential equation 9 to the power x minus x to the power 4 is equal to 65 to solve for x. Well, you are advised to watch this solution from the beginning to the end because a lot will be explained as we go along. There will be a lot of reasoning, mathematical reasoning that will have to be explained here for the choices that we're going to be making, because we're going to be making some critical choices as we reason out the solution all through. All right, let's start. 9 to the x minus x to the power 4 is equal to 65. Okay. Now, if we look at it carefully, we'll see that the left-hand side can actually be expressed as a difference of two squares. Okay. Now, let's show that. 9 is the same as 3 squared, but it was raised to the power x. And x squared, x to the power 4 can be written as x squared raised to the power 2. Okay. So we're beginning to see the difference of two squares coming out. All we need to do here is to swap the position of this power 2 and the power x. Let the x go in and let the 2 come out. So we obtain 3 to the power x squared minus x squared is equal to 65. Okay, so now we can see 3 to the power x squared minus x squared. The left hand side is actually a difference of two squares. So from here, we will now be able to apply the difference of squares identity. Applying the difference of squares identity, we obtain 3 to the x minus x squared into 3 to the x plus x squared. That should give us 65. That is it. Now, we have the product of two expressions here giving us 65. The way forward, the normal way forward is to decompose the number 65 into its component factors, from whence we're now going to form two equations. But there's a lot of reasoning that has to come along. If we decompose 65 can be decomposed into 1 times 65. 65 can also be decomposed into 5 times 13. Okay, look at these two choices. Which of these two will really match what we have here? So we have to be careful with the choice we're going to make. There will be a lot of mathematical reasoning that will govern the choice of the decomposition, the particular decomposition that we're going to use. Is it going to be the first one, 1 multiplied to 65, or 5 multiplied to 13? Now let's reason along. Now let's take 1 multiplied to 65. And so we'll have 3 raised to the x minus x squared into 3 raised to the x plus x squared, giving us what we're considering the first case, 1 multiplied to 65. We'll have 1 multiplied to 65. Now, if we look at it, we are seeing 3 to the x here. Here is addition, here is subtraction. And we are subtracting the same quantity, x squared. It therefore supposes that the value of this must be smaller than the value of this. And so if we look there, the smaller value is 1. So we're going to attach 1 to this factor. And the bigger number is 65. We'll attach 65 to this factor and see if it makes sense. So that's the first reasoning that we have here. Subtraction to give us a smaller value than addition. So this one, 3 to the x minus x squared, can be equated to 1. And then 3 to the x plus x squared be equated to 65. Now let's reason it out. If we are saying 3 to the x minus x squared is equals to 1, we can see therefore that the only value of x that will render that solution possible will be the value 0. When x is 0, 3 to the 0 minus 0 squared, what do we get? 3 to the 0 is 1. 1 minus 0 is 1. Okay, so the only value of x that will render this first equation true will be the value x equals to 0. But remember, that same value of x must also render this other equation true. So if we are saying x is 0, let's put x here and see. We'll have 3 to the 0 plus 0 squared. Do we get 65? 3 to the 0 is 1 plus 0, which is 1. 1 is not 65. Therefore, this choice of 1 multiplied to 65 is not workable. It's not acceptable. So we have to take the other choice. So this one is not possible. Now let's see this one. 5 multiplied to 13. So we just come over here and write 5 multiplied to 13. Okay, let's carry out the same analysis. This factor is supposed to be a smaller value compared to this. So we equate this one, 3 to the x minus x squared to be equal to 5. We can call that one equation 1. And then the other one, 3 to the x plus x squared to be equal to 13. We call that equation 2. Okay, now this is what we got here. These two equations in terms of 3 to the x squared. Okay, in terms of 3 to the x minus x squared or 3 to the x plus x squared. All right, remember we want to solve for x. On the left hand side here we have negative x squared, positive x squared. So you see that if we add equation 1 to equation 2, we are going to eliminate the x squared term. So let's do that. Equation 1 plus equation 2, when we add them up, we're going to have 3 to the x plus 3 to the x when we add this. And then, of course, this one just gives us 0. And then 5 plus 13. 5 plus 13 will give us 18. 3 to the x plus 3 to the x, there are two of them. So we're going to have 2, 3 to the x is equal to 18. If we divide both sides by 2, we obtain 3 to the x is equal to 9. Now 3 to the x equals to 9. This is an index expression with base 3. We can obviously change 9 to an index number with base 3. So we have 3 to the x is equal to 3 squared, because 9 is 3 squared. Alright, so the bases are equal, so we can just go ahead and equate the powers. So the value of x is 2. So with this case, we have a solution. The value of x equals to 2, but we have to check, just like we checked up here and we disqualified this choice. So let's check if this value x equals to 2 is a reliable solution. Okay, so we'll put it in the two equations and see if we get the results of the right hand side. The two equations again were, so we're checking the value x equals to 2. We're checking the value x equals to 2. Remember, our first equation is 3 to the x minus x squared equals 5. Okay, and let's check here first. When we put x equals to 2, we're going to have 3 squared minus 2 squared is 4. Okay, do we have 5? 3 squared is 9 minus 4. That gives us 5. So it is valid there. The second equation is 3 to the x plus x squared. Do we have 13? X is 2, so we have 3 to the squared plus 2 squared is 4. 3 squared is 9. 9 plus 4 gives us 13. And so the value 2 is an acceptable value. But let us also bring it over here and see if we also have a complete agreement with the left hand side expression and the right hand side expression. So coming over there, we have 9 to the power 2 minus 2 to the power 4. Do we have 65? 9 to the power 2 is 81. 81, 2 to the power 4 is 16. Now 81 minus 16, clearly it is 65. So we have verified that the value x equals to 2 is the right solution to our exponential equation.